sparking both conspiracies and closing key infrastructure. You see, the modern solutions to working with drones is just detection. There's no answers. There's no classification. Our upcoming paper from the Drone Lab of College of Charleston aims to address this. 4,500 Seconds aims to use AI models to classify drones at a small scale. Authored by me, Andrew Berg, and helped by my mentors and co-authors, Dr. Wynn and Dr. Zhang. What are we going to talk about today? First, I want to further motivate this work and why it's so important and why it's not just going to go away. Next, we're going to talk about modern methods used to classify and detect drones in the road. Then we're going to touch upon data scarcity and why this is a problem that needs to be solved and how our data set overcomes that. Then we're going to put it all together in our proposed system and show off our initial results. So, from a early 2024 survey from Market US, the drone analytics market and drone market at large is growing and projected to grow exponentially. This is in the billions, and by 2033, there should be about $54 billion in the US alone in drones. You see, the problem of drones scaring civilians is just not just going to go away. There's going to be more and more all across the world and the country. We need solutions, we need answers, which is why we propose classification. So what are our options? Modern methods use cameras, radar, and acoustics, or audio. We chose audio for our solution as it's cheaper and we had prior experience. Specialized cameras are an option, but range from thousands to tens of thousands of dollars, and radar is even more expensive. There's considerations as far as range, but acoustic is what we chose. Before I continue, I'd like to define some terms so we're all on the same page. So feature extraction is taking raw audio content, such as a waveform, which you might listen to on Spotify, and what humans use, and transforming that to a better image-like format, which is utilized by the AI model. An AI model simply is an applied statistical representation of learned states, which is enabling prediction or classification in this case. What you need to know is that it takes an input, it does some amount of work with math, and then outputs. In this case, we're outputting the prediction of drones. Modern products like ChatGPT and Claude utilize this same structure scaled up to billions, if not trillions of times larger. Of course, in our system, we don't need that kind of power. Our approach takes maybe a million times of this toy example. The model is trained by updating the learned weights or mathematical equations inside of it. Lastly, I want to define data augmentation. What data augmentation does is takes raw audio content seen in blue and it permutes and changes it to be more useful and expand the data set. Importantly, we're not replacing audio, we're adding to the data set. This helps overcome data scarcity. But what is data scarcity? So, our title 4,500 seconds is about an hour and 15 minutes of actual content. This is not a lot. Modern labs use millions to billions of data points to get their models to learn. In the real world, this is not applicable. It's not worth in the real world to have such a data set. Any system that we work with needs to deal with the lack of data because of the increase of manufacturing, consumer, and military drones. This is simply not an option. Further, our data set is noisy and includes custom drones, not seen anywhere else. Let's put it all together. First, we take our input data, our raw audio content. We then augment it, inflating the data set, helping reduce data scarcity. From there, we take the augmented data set, and we feature extract, turning it into a more image-like format. We take the image-like format or feature extracted states, we put it into our model, training it and learning the weights or the math behind it. And then that can output and classify measurements. Our initial results have been extremely promising, with the worst case having an average of 93% test accuracy. This is state of the art. While these are initial, we would like to scale up the data set in future works, increasing the methods used and the number of drones that we can work with. So what do we go over today? We talked about why this problem is not going to go away, why it needs to be solved now to remove the scare and the security risks of drones in the skies. Then we talked about modern methods used and why we chose to use audio. Then we talked about data scarcity and how our data set will overcome such an issue. Finally, we put it all together in our proposed system, taking you through each point of how our system works with the data. We believe that this is a key problem, and solving it not only unlocks also the seas and the land. People demand answers and should feel safe where they live, no matter what. We believe that AI can help us get there. Thank you. Thank you.